Greetings. My name is Laurie Butgereit, and I'm from Nelson Mandela University in Port Elizabeth, South Africa. And because we haven't had a chance to meet yet or have tea together, I'd like to just share a little bit about Nelson Mandela University in Port Elizabeth. Port Elizabeth is right in the southern part of South Africa. It's in what is known as the Eastern Cape. This is the Western Cape. There's Cape Town. Port Elizabeth is not that far away. The other thing I'd like to say is South Africa right now is in lockdown, and I'm recording this from home, and there are children playing in the garden outside. Not my children, the neighbor's children. So if you do hear a couple of children, please be understanding that these are difficult situations for everybody. Okay, so I'd like to chat today about using the Internet of Things and clustering algorithms to help allocate temporary work to the unemployed. And again, just a caveat on the paper, is the statistics that were provided that helped motivate this research were collected prior to COVID-19. We wrote these papers a year ago. The world has changed dramatically in a couple of months. Okay, so the South African unemployment rate in second quarter 2019 was 29%. This statistic was provided by Stats SA. That's the official provider of statistics in South Africa. That value, 29%, however, does not tell the whole story. Stats SA also provides an expanded unemployment rate. The expanded unemployment rate includes people who have gotten discouraged and are no longer looking for work. So the expanded unemployment rate, the person was unemployed, they looked for a job for a while, they got discouraged, they quit looking for a job, and that rate is 38.5%. This employment rate, however, is not uniform throughout the country. For example, in Northwest Province, the employment rate is 46.6%. And the unemployment rate is not uniform across age groups. The youth, age 15 to 24 years, is the highest hit with an unemployment rate of 68.3%. Some of you in other African countries might feel that you understand that 68.3% also. So one of the questions this research asked is, how can we help alleviate these values? Well, one possibility is the use of the gig economy or micro-jobbing. Now, I want to say right off the top here is I don't want to get into an argument of whether the gig economy creates an employment contract or whether it creates an independent contractor relationship. That's for the courts to decide, and every country has their own laws. But perhaps the most famous or infamous of the gig economy platforms is Uber. Uber is a platform where a person who has a vehicle can provide transportation for a person who needs a lift and earn some money. Again, whether that's an employment arrangement or a contractual arrangement is for the courts to decide. Another such platform which was available in South Africa was Recruit My Mom. Recruit My Mom was a place where professional people could register for part-time work or temporary work and hopefully find employment. So for example, if a woman was a bookkeeper and she had stopped working for a couple of years to raise children, she could then register with the name Recruit My Mom, and she may be able to find temporary work after her children started school. Another platform is Money for Jam. This was perhaps more targeted towards day laborers or week laborers, but if you were a gardener or a builder's assistant or you were a plumber's assistant, you could register and hopefully earn some money by doing day labor or weekly labor using Money for Jam. Okay, so this research was done at a publicly listed company, a company listed on the Johannesburg Stock Exchange. This company developed an Android app and all the related servers, which would allow the Android app to sell airtime, data, electricity, some Wi-Fi connectivity. It also facilitated traffic fine payments, bill payments. It provided some ticketing, such as sporting event ticketing and bus ticketing. Again, that was pre-COVID-19. And it provided some gambling and lotto facilities, which was pre-lockdown in South Africa. So it provided these devices, these point-of-sale devices, free of charge to merchants. And we're dealing primarily with informal merchants, spaza shops. If you live in Africa, you know what a spaza shop is. If you are not familiar with Africa, a spaza shop is an informal trader, perhaps in a township or in a very rural area, which sells necessities. And obviously the definition of necessity in today's world includes airtime, data bundles, and electricity. The company has tens of thousands of these informal merchants with these point-of-sale devices selling these virtual products, airtime, data, electricity, and the merchant earns a commission on each sale. Just for a matter of interest, the company under research also provides these point-of-sale devices to more traditional commercial entities, such as supermarkets, grocery stores, and petrol stations. But for the scope of this research, we're dealing only with the spaza shops in the informal market. So just a very, very brief overview of the architecture of how this works is the devices are out here in the field. And let's say a customer walks into the spaza shop and wants to buy airtime on MTN, the MTN cell phone carrier. The app on the device would create a message, and inside of that message would be embedded Internet of Things information. Inside of that message is embedded the longitude and latitude of the device, nearby cell towers, how much storage is left on the device, how much battery, how the battery is doing, etc. And it would send this request to a gateway server. And at that point, the Internet of Things information would be split out and would go down one way, and the commercial information would be split out and go down another way. I don't really want to talk about the commercial path at this point, except that a voucher would be generated, and I see the diagram doesn't have arrows going back to the device, but the voucher would be sent back to the device. The device could print the voucher, and the merchant could sell the voucher to the customer that walked in the shop. The Internet of Things information, however, was stored separately, and this allowed the company to write some nice software to monitor devices. So, for example, this was supposed to be a movie, but I couldn't get the movie to play. They could get live sales displayed, where pins would drop on a Google map as the sales would come in. It would be live within a minute or so. Okay, so there are tens of thousands of these devices and merchants spread out around the country. It often became necessary that the merchants would need to be visited or the devices would need to be serviced. So, for example, just a couple months before this entire COVID-19 disaster struck the world, they started selling a new bus route on the devices. So it had become necessary that they visit the merchants and give them signage to put on their shops that they were now selling this new bus route or this new bus ticket, etc. And in order to do this, the company under research hired what they called foot soldiers. Day laborers who would go and visit merchants in a specific area, okay, and give them signs for their shop or clean the devices or talk to the merchants about whatever. But the problem was there were so many devices and they were sitting on top of each other. So for those of you who are from South Africa, you might recognize this little map snippet. This is Diepsloot. Diepsloot is just north of Sandton, north of Johannesburg, and each of those pins represent a device in a little spaza shop, okay, in Deep Sleuth. Now, it would be overwhelming to give a map like that to foot soldiers and just say, go and do this. We needed to come up with a way that these devices could be clustered together into an amount, into a cluster that one foot soldier could handle on one day. So what a cluster might look like is something like that. So that this would be a physical distance and that a person could handle on foot, and it would be an amount of merchants or an amount of devices that a foot soldier could handle in one day. So how do we do that? This is the crux now of the research. How do we create these clusters out of this mass of information? Now, for those of you who've been on computer science classes, you might be thinking right now, the traveling salesman problem. Here's a real use for it. Well, let's think about that for a moment. One of the requirements of the solution to the traveling salesman problem is that there is good information about the roads between the towns. Okay? And in Africa, that is not always the case. Granted, Google does have a roads database, and it is very good. And the Google Street View car has been up and down lots of the township areas in South Africa, but not all of them. So there was not a reliable source of information for the roads between these devices. So we couldn't use the solution to the traveling salesman problem. You can read the paper to find all the arguments of all the algorithms that we didn't use, but what we eventually used was DB-Scan. DB-Scan is an unsupervised machine learning algorithm. It's a density-based algorithm, clustering algorithm. You do give it a couple of parameters to get started with, like what is the minimum amount of elements you want in a cluster, and then it tries to build these clusters. And it builds the clusters very nicely and reasonably quickly. So with the use of DB-Scan, we can now conclude and saying, assuming that there is good geographical information, and that's a big assumption, but assuming that there is good geographical information, it is then possible to use clustering algorithms to allocate work to day laborers. So you have to have the good geographical information, then we can do the clustering to allocate the work. Now, I believe I'm going to be online to help answer some questions, but until that, you all stay safe now.